Hello, welcome back to the Stay Safe podcast, Toolbox Talk series. I'm Liam Scott, and today we're looking at something essential in every laboratory, but often overlooked because it works quietly in the background: our engineering controls. PPE and good behaviour are important, but engineering controls are different. They're the built-in systems that protect you, even when you're not consciously thinking about safety. When they're designed properly and used correctly, engineering controls will reduce exposure, help remove hazards at source, and keep dangerous substances exactly where they should be, away from you. Under UK law, employers are required to follow a clear hierarchy of control. That hierarchy makes it very clear that engineering controls must be prioritised before relying upon PPE or procedural rules, and PPE is the last line of defence. So today we're going to break down what engineering controls are, why they matter legally and practically, and what you should be checking every time you work in the lab. So fume cupboards and LEV are your first line of defence against airborne hazards. One of the most important engineering controls in any laboratory is LEV. This includes fume cupboards, extractor arms, ducted enclosures, vented chemical storage, and biosafety cabinets for biological work. These systems are designed to capture hazardous substances at source, so vapours, gases, dusts, aerosols, and biological agents before they enter your breathing zone. In the UK, this is a legal requirement under the Control of Substances Hazardous to Health Regulations, COSH. COSH makes it clear that if exposure can be prevented or adequately controlled using engineering controls, those controls must be used. But the key point of LEV, the systems only work to protect you if they are used properly. This means that airflow is working and within limits, sash heights are set correctly, the cupboard isn't overloaded with equipment affecting airflow, work is carried out inside the marked safe working zones, and alarms, gauges or indicators are taken seriously. If you see an airflow alarm, stop immediately. Don't just finish the last bit of the work, don't just assume it's a sensor fault, don't ignore it because it's always doing that. The alarm is telling you that the hazardous substance is no longer being properly contained, and continuing to work at that point may be a direct breach of COSH and a direct risk to your health. Why interlocks protect you even when they seem inconvenient? Another critical engineering safeguard is interlocking systems. You'll find interlocks on equipment such as centrifuges, autoclaves, chemical storage cabinets, high temperature ovens, UV sterilisation units and cryogenic freezers. Interlocks are designed to prevent access when equipment is operating, to stop equipment starting if conditions aren't safe, and to control pressure, temperature, radiation or movement. Under the provision and use of work equipment regulations, PURE, safety devices including interlocks must not be removed, bypassed or interfered with. And yet, incidents still happen because somebody overrides an interlock to save time or to make a job easier. People have suffered serious injuries from high-speed rotating equipment, sudden steam release, pressurized systems failures, exposure to UV radiation, cryogenic burns, and electrical risks, all because an interlock was defeated. So the rule is simple and non-negotiable. If an interlock activates, it is protecting you, and never tamper with it, ever. Respiratory protection, only effective when it fits. Some laboratory tasks still require RPE, particularly where residual risks remain after engineering controls. RPE is not a generic face covering. To be legally compliant, RPE must be suitable for the specific hazard, face fit tested for the individual, maintained and inspected, and fitted with the correct in-date filters. A poorly fitting respirator offers little more than a false sense of security. Even a small leak completely undermines its effectiveness. Filters also have a finite life. They degrade, become saturated, or clog over time. Using expired filters is effectively the same as wearing no protection at all. If your RPE doesn't fit properly, feels uncomfortable, has an odd smell, or hasn't been tested, stop and raise concern. It's your lungs. You don't get any replacements.
This podcast is being provided by Scott Risk Management, specialist health and safety consultants. If you operate an SME business, you know that meeting all of the business needs is a juggling act. If you want to simplify safety, save time, and stay compliant, SRM Genie is the solution. For more information, head to the details at the end of this episode.
Routine testing, examination, and certification. Engineering controls are not just about fit and forget. UK law requires them to be examined, tested, and maintained so that they remain effective. For example, LEV systems must receive a thorough examination and test at least every 14 months. Fume cupboards require face velocity testing. Biosafety cabinets require specialist testing and validation. RPE requires periodic inspection and refitting to the user. Pressure systems that fall under the Pressure System Safety Regulations require written schemes of examination to be written and followed. If certification is overdue, missing, or invalid, the equipment should not be used. And if something doesn't seem right, such as changes in airflow, unusual noises, damaged seals, cracked sashes, warning lights, or fault messages, report it immediately. Do not assume that somebody else already has. Under the Health and Safety at Work Act, employees also have duties, including taking reasonable care and reporting hazards. Engineering controls and human behaviour work together. Engineering controls are powerful, but they are not magic and they don't work on their own. They only work properly when people use them properly. And that means always using a fume cupboard for volatile or hazardous substances, keeping sashes at the recommended height for use, never blocking vents or airflow paths, keeping waste containers closed, working inside designated safe zones, reporting faults straight away, not at the end of the day. A well-designed system can still fail if it's misused. Final thoughts. Engineering controls are the silent protectors of the laboratory. They're working constantly in the background to protect you from toxic fumes, hazardous aerosols, pressurized systems, extreme temperatures, dangerous energy sources. But they will only protect you if you respect them, you understand them, you use them properly, you monitor them properly, and you report problems without delay. Every time you check airflow, keep the sash low, or refuse to bypass an interlock, you're actively contributing to a safer laboratory, not just for you, but for everyone around you. And that is it for today's episode of the Stay Safe podcast. Next time, we'll be looking at the backbone of scientific safety, documentation and competence, and why following the right procedure is just as important as the science itself. Until then, stay safe. Bye for now.
This podcast has been provided by SRM, the owners of the bespoke health and safety management software SRM Genie, created for and focused on supporting SME businesses. If you would like more information on how you can simplify safety, save time, and stay compliant, go to www.srmgeniesoftware.co.uk.